Okay, so before we get started with the lesson, I want to do a warm-up to go over a couple of old skills we're going to need for this lesson. So I want you to pause the video, go to the warm-up section of your binder, please copy and do the two inequalities that I wrote, and then come back and check your answers. Okay, so at this point, you've solved the two inequalities on your own, and now we're going to go over them. So, number one, of course, I'm going to isolate x. I'm going to subtract 4 from each side. So we have 2x is less than negative 4. And of course, we're going to divide each side by 2. And x is less than negative 2. Okay, this one, straightforward. Nothing really that trips people up. Number 2 is where I assumed you might need a refresher. So, of course, we're going to start by subtracting 10 from each side. So negative 4x greater than negative 10. And we'll divide each side by negative 4. What you hopefully remember is because we're dividing by a negative, right? Inequality sign is going to flip. So it's going to be x not greater than, but less than, and we'll simplify our fraction, negative, negative, positive, 10 over 4, 5 over 2, okay? So again, anytime you're dividing by a negative in an inequality, you have to turn around the symbol from greater than to less than, or vice versa. Okay, so let's get into the lesson. You did an activity on the discriminant, and hopefully learn the basics. So we're going to go through a little more advanced material on the discriminant. Okay, what is the discriminant? The whole purpose of the discriminant is it tells the number of distinct real solutions. All right, so sometimes we don't want to actually solve a quadratic equation, we just want to know how many real solutions it's going to have. The reason we want to know that is because when we connect it to the two graphs of quadratics, it's going to tell us how many x-intercepts the graph is going to have, but we'll get into that later. Okay, we also know for the discriminant, our formula is d just stands for discriminant, equals b squared minus 4ac. Where does the discriminant come from? Well, the quadratic formula is, rewrite that, b squared minus 4ac all over 2a. So the discriminant is right there. Okay, actually let me change that. So the discriminant is the inside of the square root or the radicand of the quadratic formula. So this part determines the number real distinct solutions. Okay? Okay, and then we also knew that what matters about the discriminant, the only part of the discriminant that's important is whether it's positive, 0, or negative, okay? And we want to think of positive. If a number is positive, it's greater than 0. 0, it's equal to 0. And negative, it's less than 0, okay? So we want to think of it in terms of an inequality. So if the discriminant is positive, we have two real distinct solutions. If the discriminant is 0, we have one real distinct solution. If the discriminant's negative, we have no real distinct solutions. And if we have no real distinct solutions, that means we have complex solutions. Okay. All right, so number one, determine the number of real solutions. So we're determining the number, we're not actually solving, so that's why we need the discriminant. So the discriminant here would be 1 squared minus 4 times 2 times 7. So this is 1 minus 28 minus 56, which is negative 55. So our discriminant here is negative, so this is no real solutions. Okay. Number two, we have to change the form here because it's not in the standard form of a quadratic equation. We want to rewrite this as 4x squared plus 3x minus 3 equals 0. So the discriminant, so we have 3 squared minus 4 times 4 times negative 3. And let's continue over here. That's 9 minus 12 times negative 4 plus 48. So the discriminant is 57. So we have a positive discriminant, means this has 2 real solutions. Okay. The next questions are different. We want to know for some value, this one, number 3, h. For what values of h is this equation not going to have any real solutions? So this means no real solutions, means the discriminant is negative or less than 0. So we want discriminant less than 0. Let's set it up. We want b squared minus 4ac to be less than 0. Okay, so b here is 7 minus 4 times 4. We don't know the value of c. Instead of c, we have an h, so we'll just substitute an h. Okay, simplify. 49 minus 16h less than 0. Okay, so now we have this inequality to solve. So negative 16h less than negative 49. I'll divide by negative 16. And we're dividing by a negative, so our inequality symbol flips. So we have h is greater than 49 over 16. We always want to try to simplify. 16 is divisible by 2, which doesn't work for 49. 16 is divisible by 4, doesn't work for 49. It's divisible by 8, which doesn't work for 49. So we have it in simplest form. So any h that's larger than 49 over 16 will give us no real solutions. Okay, so 49 over 16 is a little bit over 3, which means if I were to replace h with 4 and then solve that quadratic equation, we would get something involving I, something that doesn't have any real solutions. It has only complex solutions. All right. Number 4, we want to know the value of h for which the quadratic equation has one real solution. One real solution, it means the discriminant is equal to 0. So we want b squared minus 4ac equal to 0. So b here is 5. And h, we're going to substitute in negative h. Okay. So 25 minus 36 times negative h plus 36h equal to 0. Okay, subtract 25 from each side. So 36h is negative 25. 36 h equals negative 25 over 36. See if we can simplify. 36 divisible by 2, doesn't work for 25. The only thing that's 25 is divisible by is 5, which doesn't work for 36. Okay, so this is simplest form. And the last question, two real solutions, which means the discriminant is positive or greater than 0. So we want b squared minus 4ac to be positive. Substituting, that's 9 squared minus 4 times 8 times k. 0, 81 minus 32k greater than 0. Let's come up here. Subtract 81 from each side. Okay. Negative 32k is greater than negative 81. Dividing each side by negative 32. So we are dividing by a negative here, which means the inequality symbol does flip. So we'll have k is less than 81 over 32. The negatives will cancel. And 81 is only divisible by 81, which of course doesn't work for 32. It's also divisible by 9, which doesn't work for 32. So this is simplest form.